All right, so rate of change is slope, rise over run, y2 minus y1 over x2 minus x1, which is the change in y over the change in x, and a lot of times we refer to slope as the letter m. So we have 1, 2, 3, 4, 5, 6 different things right now that all mean the exact same thing.
Oh, isn't there y mx plus b?
Yes, that's slope-intercept form, and we're going to do that in a couple days. Okay, so we're not quite there, but see, you guys have heard this stuff before. So the first thing I want to talk about is when a line is increasing over time. Its slope for that line, because it is increasing, is going to be a positive slope. If a line is going down over time, it's going to have a negative slope. If you have a line that is going horizontal, so straight across, if I were to set a car on that line, and it doesn't have a hill or a slant down or anything, how fast is that car going to move? It's not moving, so our rate of change would be 0. And then if I had a vertical line, and I set a car on the side of a vertical line, what happens to it? It falls, it crashes, doesn't it? It falls off of there. And my slope would be undefined. Yep, this is my buddy, Mr. Slopey. This is my buddy, Mr. Slopey. He helps us decide on some of our slopes which way they're going. So again, if it's rising, it's a positive slope. If it's going down, it's a negative slope. If you have a vertical line, your slope is undefined. If you have a horizontal line, your slope is 0. Well, it's kind of like his chin dimple, isn't it? Anyway. All right, so let's talk about the different times we're going to use this. Now, I'm going to scroll back to the top again real quick. We're going to use these different words at different times throughout this lesson. So, for example, all of the time we're looking for slope. But in the first couple, when we're doing it from a table, we're going to look at it as the change in y over the change in x. So this is when I have a table that I'm working from. If I have a graph that I'm looking at, then I am going to do rise over run. So I use this one when I have a graph. And if I have 2 points, then I am going to use the equation one. So this is if I have points. So we're going to have different opportunities depending on what we are doing today. All right, so we are going to actually jump in with example number 1. All right, so for example number 1, I want you to determine and explain the rate of change. And we're going to start off by doing it with a table. So in my table on the left is my independent side, and I'm going to call this side minutes. On the right, I'm going to label it as feet. That's my dependent side, right? So maybe after 2 minutes, I have traveled 9 feet. After 4 minutes, I've traveled 19 feet. After 6 minutes, I've traveled 29 feet. And after 8 minutes, I've traveled 39 feet. So the first thing I have to do is find that rate of change. I got to determine it. When I say the change in y over the change in x, that means I am subtracting my y's. So I'm going to do a loop. 19 minus 9 equals 10. On this side, I'm doing the change in x. 4 minus 2 is 2. So I take the change in y and divide it by the change in x. I get 5. But I have to make sure it matches through the entire table. All right? Or I won't have a slope. So again, I'm going to go 29 minus 19, which is 10. On the left, 6 minus 4 is 2. So I again get 10 divided by 2, or 5. Let's do it one more time. 39 minus 29 is 10, and 8 minus 6 is 2. So my rate of change is 5, but now I got to explain what it means, right? When I said the change in y, that meant the top was feet, and then divided by the change in x, the bottom was minutes. So technically this 5 represents 5 over 1, or 5 feet per minute. So that's what we're going to say. We're going to say 5 feet per 1 minute. So again, the first 2 problems you have in your homework today are from tables like this. If you do not have the same rate of change to the whole thing, you just say it's not constant and you don't get to do anything. If they all match, like this one does, then you've got to explain what the rate of change means. So this actually covers problems 8 through 10. Any questions so far? We're all doing good? Okay. Now, I want to give you guys a couple graphs we're going to stick in our notes. I'm going to have you take one sticky first and put it as example number 2. I hope. Yep. I don't want to leave you out over here. There you go. You're very welcome. 2, 1, 2, 1, 2. And I can, of course, count 1, 2, 3, 4, 5, 6. I'll let you take control this time. All right. I want you to take one of these beautiful stickies and put it at example number 2. Make sure your y is to the sky and x goes to the right. Nope, this is going to be example 2. All right, we have example number 2. Now, when you put your graph or your sticky, again, the y is to the sky and x is on the right. I'm going to have you plot 2 points for me. Let's start by plotting the first point at -3, 1. I want you to put a dot. And the second point, let's go at 4, 3. Put a dot. And connect your dots for me. So you have this line going through your 2 dots. Now for example number 2, I'm going to ask you to find the slope. Now when we're finding the slope from a graph where they give you 2 points, you are going to think of it as rise over run. You always start at the leftmost point. So out of those 2 points I have up there, the leftmost point is this one, right? So the first thing I'm going to do is I'm going to count my rise. In order to get to my other point, I'm going to rise up 2. So I have 2 on top. And then from there, I'm going to run to the right. 1, 2, 3, 4, 5, 6, 7. My slope is 2 over 7. No, I said 4, 3. Over 4 and up 3?
No,
On that same graph, I'm going to have you plot 2 more points for me. Will you plot the point 2, negative 1? And how about the point 5, negative 3? Negative 2, negative 1, sorry. Negative 2, negative 1, right here. And then positive 5, negative 3. And again, go ahead and connect your dots. All right, so again, we're going to do rise over run. But this time when I go to my leftmost point, in order to get to the right point, am I rising up or am I rising down? So what do you think that's going to mean for my first number? Yeah. So from here, I'm going to go down 1, 2. So I have a negative 2 on top. And I'm going to go to the right. 1, 2, 3, 4, 5, 6, 7. So my slope is negative 2 over 7. How we doing? Doing good? All right, let's do example number 3. And again, I want you to use a sticky for me. So going on to example number 3. When you put that sticker in there, make sure, again, your Y is to the sky. And X is on the right. All right, so this is problems numbers 12 through 16. And all it's going to say is find slope. All right, again, this time let's plot the point negative 4, 3. And let's go with 2, 1. All right, so when we do rise over run, the first thing we're going to do is start counting which direction. We start at the leftmost point. So out of these 2 points, this is my left one, right? Okay, so to get to my other point, do I count up or do I count down? Down. 1, 2. I'm going down 2, which means I have a negative 2. Over. And then I always go to the right. 1, 2, 3, 4, 5, 6. Negative 2 over 6. Does that reduce? To what? Good. Negative 1 over 3. Very good. And if you do that and you reduce it to negative 1 over 3, let's go back to our point. If I go down 1, because that's what that's saying, right? And then I run to the right 3, 1, 2, 3. Did that also follow my line? And then I can go from that one, down 1 and over, 1, 2, 3. And I can repeat it over and over again. Any questions? Doing okay? All right. So you have 3 just like this. You look in your book, you count the points from the left point to the right point. That's all you have to do. All right? We're all good? Okay. All right, example number 4. Again, I'm going to ask you to find slope. But this time, I'm going to give you 2 points. My first point is the point 3, 7. And the second point is the point, how about 5, 8. Now, when we're going from 2 points, that's where we use that equation we started with, which was y2 minus y1 over x2 minus x1. Now, where those come from are in the points. This first point is my x1, y1, because that's my first point. My second point is my x2, y2. So that tells me what numbers I'm going to plug into this equation. So the first one that comes up is y2. Which of those four numbers is y2? 8. Very good. Minus my y1. Which number is y1? 7. Nice job. Over x2. My x2 is right here, so the number is 5 minus x1, which is 3. So my top line, 8 minus 7, is 1 over 5 minus 3, which is 2. Let's do it again. In that same example, how about if we have the point? Negative 3, 5, and 4, negative 1. So again, I like to label above those points. So this is my x1, y1. This is my x2, y2. And again, we're doing y2 minus y1 divided by x2 minus x1. All right, so which number is my y2? Negative 1, right here. y2 is negative 1. So I have negative 1 minus y1. y1 means in my first point, the y value is 5 over x2. Second point, my x value is 4 minus negative 3. Now you can either write negative 3 like that, or I like to put it in parentheses, because then it makes me see what do I have to do with those two negatives. They got to become adding, right? We sandwich them together, and this becomes a plus. So on top, I have negative 1 minus 5 is negative 6. I agree. How about 4 plus 3? It's 7. Negative 6 over 7. Can I reduce that? No. That is our slope. Any questions so far? This is really easy. Okay. So this is what you are doing for, in case you're referring back to it, problems 18 through 22. Example number 5. All right, for example number 5, and then I'm going to come back to some middle ones. This is going to cover your 26 through 32. All right. I'm going to ask you to, without graphing, find the rate of change. And rate of change just means what? Slope. Thank you. Thank you, thank you. Rate of change just means slope. Now here I'm going to change it up a little bit. What if I said to you, a babysitter earns, earns, I got to get an N in there, earns $13 for 2 hours and $39 for 6 hours. All right, so I want you to find the rate of change or the slope for this, which means we need to take this statement and put it into 2 points. All right? Our first point is going to have an x and y, and our second point is going to have an x and y. My first point is going to be this first line. Now here's my question. I have money and I have time. Which one is independent? Very good. So it's going to be 2 and then 13. Right? Time is independent. And of course, the amount of money you make depends on the time. My second point follows the same thing. So that point is going to be the point 639. All right. So now again, this is my x1, y1. This is my x2, y2. So y2, good, minus y1. 13, good, over x2, which is 6, minus x1, which is 2. So on the top, I have 39 minus 13, which is 26, over 6 minus 2, 4. Now this reduces to 13 over 2. But isn't this a real life situation? So what do you think we should do? Make it money, exactly. Make it a decimal because it's real life, right? So what is 26 divided by 4? 6.5, or since it's money, it's 650. What does that mean? 650 per what? $6.50 an hour. Not the greatest money in the world, but you know.
I charge per kid. Like, I have that rate and then do like $10 if you have more kids. So if like someone has like 12 kids, I mean like.
All right, last thing I need to talk about very, very quickly. Last thing I want to talk about is when we had Mr. Slopey, we talked about a horizontal line. If I have a horizontal line, so the line goes like this, and again, if I have a car sitting on that horizontal line, there's my car. My slope, or how quickly would it be moving, is, what did you say, Madison? Nope. 0. It doesn't move at all, right? It's sitting on that line. If it doesn't have like a valley to go into or a slope to go up, it has no rate of change. So my slope is 0. And I'm going to write it as m equals, we like to refer to our slope as m equals 0. If I have a vertical line, vertical line, which means my line goes up and down, what happens to my car? It falls. So my slope is undefined. Now, before we move on to the next part, or the last example we're going to talk about, I want to talk about the horizontal line first. When we say this is rise over run, right? If I had a point on this end and a point on this end, how many am I rising up to get to the other point? 0, right? Over some number. If you have 0 over a number, you can take 0 and divide by 4 and you still get 0. So that works. However, if I had 2 points down here, which means I would rise up a number and divide by 0, can you do that? If you were to put it in your calculator, 4 divided by 0, what happens? It tells you an error. Exactly. It is undefined. It does not work. All right? So I wanted to clarify those two things and what can happen. So here is my last example today. I think I'm on what, 6? Okay, example number 6. And it says find the slope. Pretty much the directions all day, isn't it? All right, and you're going to look at a graph. So let's say you have a graph. In the first graph, they give you a line like this. What is the slope? 0. You just put m equals 0. If they give you a graph and the line looks like this, what is your slope? Undefined. M equals undefined. That's it. In that section, yes. You just look at the picture. If it goes this way, you say 0. If it goes this way, it's undefined. Now, there's only 2. But, I mean, we're going to get more and more as the chapter goes on, but I need to make sure we understand this, because I'm going to tell you, on our test for this chapter, about 50% of us mix them up. So I want to make sure we're clear and we understand the difference. Yes, today there aren't very many. All right, do we have any questions? All right, so we are on page 298 to 299. We are doing 8 through 32 even. The very first 2 are a table, like example number 1. If you do the whole table and they don't all match when you do change in y over change in x, then you have to say it's not constant. All right? Hint, hint. And it's uploaded in Google Classroom. Uh-huh. That's fine.